starting to build on the Skymaster 1.6 F-16. We're going to start with the vertical stab. So before we do that, we are going to look at our hardware package and identify what the rudder will need. So here's all the stuff that I took out, and for now we're going to put away all the air and gear. This is a light controller aside. We're going to focus on this, and in here we have this little nubbin right here, but essentially this guy is supposed to go in here, mount like that. This goes into a servo arm, and we'll show all that once we get to that step. So I've cleaned out the paint, and it looks like the receptacle in the rudder here is actually metal. Metal over metal is still gonna wear, so I'm not sure how to approach this. I don't know if there's a way I can epoxy something, and yeah, I don't know. But I'll just try to put this in there to put that ball end in there and see how it works out. Then we'll go from there. This is the servo we're going to use for that. It's a FreeSky BLS 54.5H. It's got plenty of torque, somewhere in the 20 or 30 kilograms, I forget exactly. And basically what we're going to do is, I haven't figured out exactly how long my servo arm should be, but I'm thinking it's going to go something like that. And then the ball end will be attached to one of these receptacles or one of these threaded holes. Obviously I need to drill that out because this end is a M4 and this is an M3, and that's where having tools comes in handy. I have this drill bit here, which is a M4 by 0.7. Usually most of our M4 threads are about that spacing. I'm going to use that, and I believe it's going to be one of these two holes in here. I think I'll start with this one, expand that one. That way this guy will be able to go in there and be locked in place, and I'll show you what that result looks like. I've drilled and tapped a hole, and you can see it looks pretty good, and hopefully, yep, that fits perfectly well. So we have threaded servo horn here, but I'm gonna see if I have a lock nut. Hopefully I don't need this to space. Everything works out. I'm hoping that the sort of the spacing between this level right here and the top of the ball link, which is where the rudder goes, that is perfectly spaced, and then that way I'll just need to have I guess I use a lock nut. I like to use lock nuts on the bottom just to make sure that this doesn't go anywhere. Technically it's not going to because I threaded it through a servo arm, but you can never be too safe. So that's what our setup is going to look like. I need to try this. Obviously I need to center this servo because my thought is that it's going to sit, front of the plane is that way, back of the plane is right here. It's going to sit like this, and rudder's going to come on top, and I want this to engage the bottom perfectly. So here we are, just checking the fit, and if we look in there, I don't know if we can see that, it looks like the ball link is perfectly engaged onto the rudder. So you can see that the bottom of the ball link is just not showing because it's perfectly inserted into the rudder. So that fitment looks correct, and this is why I use that servo horn, trying to get everything lined up correctly. I may trim it. I don't know if I'll trim it or not, but so far so good. So now the question is, how do we secure the servo down? So let's show you what that looks like. And basically you can see that there's a nice piece of wood for the servo to sit in. So what I'm going to do is just center the servo in that pocket, and we will screw it down. Obviously the servo pocket was really tight, so getting this servo in there just requires a little bit of finagling, but nothing out of the ordinary. So we're going to secure that down, test it again, and then figure out the cover that goes up top of the rudder servo. So now that we like the fit, we're going to take everything apart, and we've added Loctite to all the constituent parts. I tried using a lock nut, but that's just too wide, so instead we're going to use the regular nut that came with the assembly, and we're just gonna Loctite it, and that's gonna be that. So we're gonna stick this guy in here, get a few turns in, clean that up, and then get the backside on. And so the thing with Loctite is, I believe the absence of air is what causes Loctite to cure. So we want to tighten this pretty good so that the Loctite can cure and do its job, holding everything together. And as you can see, I'm using a wrench because the top of the ball end here has a hex pattern, which is kind of nice, so that we can really tighten this without damaging the surrounding surface. So there we go. I have Loctited these guys as well, and I might cut this off and then we'll stick this back in the jet for the final time. Result, decided to trim the control horn, sorry, the servo arm, so that's looking good. Trying to treat the holes with a little bit of CA. We formed the threads, but we want to preserve, and I like to treat the edges as well, just to make sure that it doesn't, you know, come unraveled or anything. Just a little bit of CA, and that's that. So in soaking that wood with CA, once it cures, it's gonna just add to the structure. You can see right here where it was starting to delaminate a little bit as I drilled through, so that should help keep everything where it needs to be. Okay, so I've put some ink, some paint on the top of that. Let's try this. So I'm gonna hold this down, and hopefully if I move the servo back and forth, it's plugged in. If I move the servo back and forth, it'll leave markings where this, where I need to cut it from. So let's see. Gotta hold this down pretty well. Let's see that. Okay. I'm trying to really push down on the covering. Okay, so we can kind of see that traced out, and that's the path. So we're just gonna cut that a little bit at a time and fit it back in. So here's my cutout, and I just made that with my Dremel with the end mill cut. And so we'll just try this and see if we got the general. So you can see there, I just need to come out this way a little bit, and we'll do that and get that all squared away. So we generally have our shape, and you can see that travels nice in there. So we're just gonna refine that, maybe give it a little bit more room to the edges there, and then we're gonna be done with that. I guess we have to figure out how to mount it. So now that we have our general shape, I'm just gonna take a file and just you know, finesse the shape so that it's not super rough looking, but honestly it doesn't really matter because nobody's gonna see this bit. It's just gonna be sitting under the rudder, but because I like to be clean and like a clean build, we're gonna clean it up. I think that looks pretty good. So let's test it. Test fit it again. I like that. Okay, pretty good. So I get to the full range. So full range is right about there and there. That's perfect. So to screw this plate down, I found these round pan head tapping screws kit. And I think I'm going to use something in the neighborhood of 1.7 by either 6 or 8 millimeters. So let's pull that out and see what that looks like. Yeah, here we go. Maybe 1.7 by 6. So that's the size of screw I'm going to use. Maybe 2, maybe 3, I don't know yet. Yeah, so these are tiny and they'll go into the wood blocks right there. So I'll mount those and then we'll get back to business. Alright, so I had initially thought that I'm going to screw it at the top here. Obviously the problem with that is that the rudder has a very tight tolerance, so that's not going to work. So instead I went through the side. There's some material to hold the screw from inside, and so I think that'll actually work better. And I can line that up obviously with the rivets, and using my tool here I can make very precise holes to sort of secure the screws. Yeah, that's better. Right there. Just like that. And so 2 on each side, and that cover plate's not going anywhere. Okay. Yeah, so there you can see what I was talking about. Very tight tolerances in that area. So unless I could countersink them completely, it wouldn't work. And I think the side work was better. So here's another thing I want to point out. You can see that right under there's a very thin gap, and I had to sand the rudder to get that, because otherwise you can see how if you don't, it will interfere as the rudder is operational. So that's something to keep in mind. It just feels like this was oversized and wouldn't otherwise work well. So notes on this mechanism. So it's not very tight. You can see that there's a little bit of play in there. I'm gonna see if I can work that out, but it feels like it's all coming from, you know, the base of the rudder here being able to move around. So I think if that was secure, that would be a little bit better. But you can see that I sanded that down a little bit. I might put some CA on the white exposed parts just to make sure stuff is protected, but there you go. I pulled the rudder apart because I did not like the amount of play that was in it. And, I mean, I flew my previous one and it had that, but just felt like I needed to do something about it. So what I decided to do, what I evaluated and figured out, was that I think what's happening is that the bottom part of the rudder here is not secured to the vertical stab correctly. So when you put the receptacle here onto the ball, even though this is really tight, if you have movement around here, this becomes a pivot point, and then the rudder is kind of can flop around this point. So if I look at this, the support is quite high up there. So I'm gonna put one more here and see what that does. So basically I'm gonna add one more of these guys much lower here. Hopefully that's gonna stabilize the rudder. I also found that some of these holes were too big, so I put CA in there and then re-drilled them very carefully, so the rod now that goes through there is much tighter. And I did the same thing on here. So I'm gonna try and see if this is gonna work. I have some FR4 material here, and I've already measured that, so that's where I'm gonna drill the hole, and that's gonna sit sort of like that, but I'm gonna attach it obviously to the back side here. So that's what we're doing, and hopefully that gets my rudder to be a lot more stable. So here's the final result. You can see the hinge support that I just added, and now we are gonna go test and see if this worked. Basically adding this here was pretty straightforward. After I cut the piece, put it in here, put the securing rod through just past it, and then fit that onto the vertical stab. And then I just used CA with a nozzle tip, just like that, so I can get under here and reach that and glue it in place. So hopefully this gets the rudder to be much more rock solid once it's on the plane. So that did it. Oh yeah, that is way more solid. Look at that. Moves just fine. That is really solid. Barely any play, very small amount. So that's the cure. You just need to have this hinged really close to the bottom. I was right, because basically if there's no support here, then this spot where the receptacle in the rudder gets merged into the ball end acts as a pivot, and the rudder will play around here. So by adding that extra support right there, that is rock solid. I'm very happy with that. Big improvement. So what's left now is securing the rudder. You can see the screw over there. Two choices. I can either use an L wrench to get in there, or I can line this up to the fuselage and drill a hole from the outside. That way I can get a wrench directly in. So that's probably what I'll do. So we'll get that done, and yeah, we'll be good. So you can see that we drilled a hole there for the tool that I'm going to use to tighten the clamp for the vertical stab. And basically all I did here was get a piece of metal like that and then line it up as closely as I could. This is going to be hard to show this, but basically use this piece of metal to line it up to there so that I know where I'm going to drill. And once I got that, I just use a drill bit to sort of score that. Once that penetrated on the outside, I just drill that right through. So pretty straightforward. And now we have our access hole for getting to the rudder clamp. So the one thing I gotta do before finalizing this is I like to add lock nuts to these screws that secure things in place. So for example, the rudder. So here's my M4 lock nut, and what I'm gonna do is I'm gonna add that to the end there. And the reason for that is not to tighten, is not to secure, to tighten the assembly here, because this is threaded, but it's so that I know when I'm loosening the securing screw, this will keep that in place, so I know when I've gone too far and it's loose enough, and then I can tighten it as much as I need. So it's just really to secure this M4 screw so that it doesn't fall off. And then with the help of my wrench from the outside, I'm just gonna tighten everything down just like that. And you can see there's a gap in here. Again, the point of this is not to hold this, is just not to hold the assembly, just to keep this screw in place. Here's the light connection. You can see there's two wires, and what I'm gonna do is encase the wire in snakeskin, heat resistant snakeskin, obviously because the turbine pipe's gonna come right through here, and this wire is gonna come down from the top. So we'll do that for this, as well as the rudder wire, which is sitting here, but which will drop through this spot right here. So here's the rudder pocket, and the harness I just installed. So here is how I like to do this. Basically bring the harness all the way up to where the servo is, so that if you ever have to change the servo, it is pretty simple. So basically that comes out the bottom right there. These two, this is the light here, this is the rudder servo. I'm gonna put them, line them up together in the snake skin, and then work their way all the way to the front. So that's that. And then here we've just taped this we're gonna sear it and epoxy this in. So the plug for the navigator light at the top of the tail is done. So it just plugs in here like that. The servo wire is gonna come out the bottom, and with that we're gonna install the rudder, hopefully for the last time, and screw it in place. Here's the amount of travel that we have on the rudder. It's plenty. That'll be just fine, especially for holding a knife edge. Perfect. Perfect. Okay, so pretty solid when centered as well. So that's good. I'm happy with the result. I'll move on with that.